Okay, first thing you need to understand with this question is just, um, what's in a deck of cards. All right, so first of all, there are 52 cards in a deck. I'm sorry if this is background that you already know, but some people don't know how to play with a deck of cards, so let's go over that. Again, 52 cards in a deck. There are 4 suits, right? There are diamonds, hearts, clubs, spades. All right. You don't need this for this question, but the diamonds and the hearts are both red. The clubs and the spades are both black. All right, so they're divided in half that way. And then within each of the suits, there are 13 cards. And within each of the suits, there is an ace, king, queen, a jack, and then 10 through 2. All right, so that's a total of 13 cards in each, and there's those cards in each suit. All right, so for this question, if it's asking for a probability of B union D, that means or, okay? The U up, a U shape is or, right? So the union means or, and or means add, right? The upside down U, which is also called intersection, that's and. So that would be like, what's the probability of a card being both of these things? And that's where you would multiply. Again, but this question is a union, so it's adding. All right, so we know that. It's also only talking about B, which is probability that the card's jack, and D, probability that the card's a 4. The true formula for a union would be probability of, I'm going to use just generic letters here, A union B minus, I'm sorry, the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersect B. All right. So the probability of each thing separately is added together, subtracted by whatever the overlap is. In this case, if we're talking about the probability that you're getting a jack or a 4, a card cannot be both of those. Okay, so there is no intersection, which is why the formula for this one is just going to be the probability of B plus the probability of D. All right, so the answer to this question would be your A. Let me give you a hypothetical since we're here. What if the question? So I'm going to erase this stuff. So again, I answered the question that was asked here. What if there was more information here? All right. What if there's a different question? What if it was probability of let's say A union B. All right. So for this one, it would be probability of A, which is probability of getting a diamond card, plus the probability of B, which is the probability of getting a jack. And then you would have an overlap because there is a jack of diamonds. So within the diamond cards, there is a jack. So there is overlap. So you have to subtract that out because you're not going to count that card twice. If you're just counting all the, so let's actually figure out this one out. Probability of A would be, well, how many diamonds are in the entire deck? Well, there's 13 diamonds out of the 52 cards. So the probability of A would be 13 out of 52. what's the probability of getting a jack? There are 4 jacks in one per suit, so there's 4 total, right? So it'd be plus 4 out of 52. The reason why you're going to subtract out the intersection or the overlap is because the jack of diamonds is included in all the diamonds, and the jack of diamonds is included in all the jacks. So it's counted in both, but it's not 2 different cards. It's 1 card, so you're going to subtract it out. So there's only 1 of them, so it's 1 minus 52. Again, this question had nothing to do with numbers. I'm throwing that in there as something you might see moving forward. All right, so 13 plus 4 is 17, minus 1 is 16 out of 52. So that would have been the answer to what's the probability of getting a jack or a diamond. Back to the original question, if you want to throw numbers into that one, well, the probability of B, we already talked about, is 4 out of 52. Because there's 4 jacks in a deck. There's also 4 fours in a deck, so the probability of D would also be 4 out of 52. All right, so then the answer, if we were talking about the actual probability of this, would be 8 out of 52. And yes, you could certainly reduce. I suppose it would be 1 out of 13 for each 4. So it'd be 2 out of 13 for this one. And then the other hypothetical question I gave you, 16 out of 52, would be 4 out of 13 divided by 4 out of all those. All right, so I hope that helps. I gave you more information than was asked, so I hope that wasn't counterproductive and confusing. But again, the answer to this question is A. Again, please send me your questions. I will make a video of any question you send me, and I will send it to you directly. And then I'll also post it for anyone to see if you want to go in and see what other questions have been asked and answered. Again, stay safe, stay healthy, and I'll talk to you all soon.